Our first question on this exam asks us to predict the major products for a series of reactions. In part A, we have the ring opening of an epoxide, and it's always critical to remember in the opening of an epoxide that whether we're working under acidic or basic conditions has a significant role in how that reaction works. So our negatively charged nucleophile here, the anion of ethanol, means that we're working under basic conditions. And under basic conditions, we know that the nucleophile will attack at the less substituted carbon of the epoxide. So we get opening of the epoxide, the nucleophile ends on the less substituted carbon, and the OH on the more substituted carbon. Part B is a reaction we've seen many times before. This is a nucleophilic substitution reaction, and because we're in ethanol, we know this has to be an SN1 reaction. The protic solvent leads to the carbocation mechanism. This reaction also may look familiar to us because it's very, very similar to one of the reactions we did in our week 1 experiment, our SN1, SN2 experiment. In fact, this one looks quite a bit similar to crotyl chloride. And it looks similar in that even though it's going to form a primary carbocation, our carbocation will be adjacent to a double bond and is stabilized by resonance. Therefore, the reaction can still take place. Also critical to remember in this reaction is it's the ethanol that's the nucleophile and not the silver nitrate. The silver nitrate in this reaction serves the role of facilitating the reaction but doesn't show up in the products. Part C is a sodium borohydride reduction. We know that sodium borohydride is able to reduce aldehydes and ketones. And we have a ketone here in this molecule, so our aromatic rings will be untouched, and our ketone gets converted to an alcohol. Part D is a PCC oxidation, and we know PCC can oxidize alcohols. But the alcohol given in this question is a tertiary alcohol. And tertiary alcohols cannot be oxidized further. There's no hydrogen on the carbon that needs to lose one, and therefore this reaction won't do anything. Jones reagent is another oxidant. This is the more complicated oxidant because it gives us a different product for primary alcohols versus secondary alcohols. Again, it won't oxidize tertiary alcohols, but we know that any secondary alcohol will be oxidized to the ketone. In addition, we also know that any primary alcohols will be oxidized by Jones reagent to give us the carboxylic acid. And given the fact the problem tells us we have excess Jones reagent, we know we have more than enough of the reagent to fully oxidize all of the alcohols. Part F for this question, we have a strong base with protic solvent. We know that this will be an elimination reaction, and because of the protic solvent, we know it's most likely to be an E1 elimination. And we also know that eliminations based on Seychev's rule prefer to give us the more substituted alkene. Part G is a Claisen rearrangement. Now, if you're taking this course at this point, this is material that I've generally moved all the way to the end of Organic 2. So if you're studying for Exam 1 right now, you probably haven't seen this reaction yet, but we will see this reaction at the end of the course, and so I'll include its answer here. But this is the Claisen rearrangement, which is one of the few reactions that we have for ethers. And finally, for this first question, part H, PCC oxidation. PCC, when working with a primary alcohol, will oxidize to the aldehyde and stop there.